Unit 13. Sink or float. What happens when you drop an ice cube into a glass of water? The weight of the ice cube pushes away some of the water, and the level of water in the glass rises. But that is not all that happens. The water also pushes upwards against the ice cube. We call this buoyancy force, and it makes some objects float in water. Buoyancy is the opposite of the force of gravity. Gravity pulls an object down towards the earth, while buoyancy pushes it up. If the buoyancy force is greater than gravity, the object floats. When buoyancy is less than gravity, the object sinks. To determine which force is greater, we have to compare the density of the water with that of the object. Density means how tightly a substance's molecules are grouped together. The Greek inventor and mathematician Archimedes is famous for being the first to write about buoyancy force. He noticed that when he stepped into the bathtub, the water level in the tub got higher. It was being pushed away or displaced by his body. Following this observation, Archimedes performed some experiments and came up with the Archimedes principle. It says that the weight of the water displaced by an object is equal to the weight of the object. You can see the effects of buoyancy force in a simple experiment. Fill 2 regular-sized jars with fresh water and drop 1 egg in each jar. Each egg should sink to the bottom because it is slightly denser than the water. Now, add several tablespoons of salt to jar number 1 and stir until it dissolves. You should see the egg begin to rise. This happens because salt water is denser than fresh water, giving it a greater buoyancy force with which to push up the egg. Nothing has changed in jar number 2. The egg is still denser than the fresh water, so it remains at the bottom. We can predict whether something will sink or float by examining its density. Metal is very dense, so if you drop a nail into water, it will sink. Wood, on the other hand, is not very dense. If you place a block of wood in water, it will float. The buoyancy force of the water is enough to keep the wood from going under.